It takes about 90 minutes to assemble a computer. Its hard drive disk saves information transmitted to it for a long time. The reading head reads the information. It is extremely precise. The space between the reading head and the hard disk is as thin as a hair. The hard disk is installed in its position within the computer. There are two other units which safeguard information: the removable 3-inch disc reader and the CD-ROM reader, which allows for the reading and execution of programs recorded on compact discs. These two units are placed into position. The spinal column of the computer is the motherboard. It is to this unit that the other elements of the computer are connected. This cooler dissipates the heat generated by the chipset. Certain sound cards are integrated directly on the motherboard. These connections, in sequence, are the audio input, its output, and the microphone port. This AGP retaining ring secures the video card during transport. This thermal unit measures the temperature emitted between the processor and the motherboard. The processor is the brain of the system. It interprets, calculates, and executes the instructions given to it. The processor has several millions of transistors, and its cadence, its operating speed, reaches the gigahertz level. The processor rests on this base. The processor's cooler dissipates the intense heat. Its efficiency depends on the type of material used, and a conducting material assures better cooling. The RAM memory stores short-term information, but erases it when the current is turned off. This memory is more rapid than that of the hard disk or the CD-ROM. Now they integrate everything in the case. It protects the internal elements from the external elements. At this stage, they install the electronic components in this case. Several connectors of the case are connected to the motherboard, such as the commutator and various light indicators. This is the output connection for the video card, which links the computer to the monitor. We also see the video chip, which creates images in 2 and 3 dimensions. Here is the video memory. The more its capacity is increased, the clearer will be the image displayed on the monitor. The video card is placed into its position. The modem allows two computers to communicate. Its condensers produce the perfectly clean phone signal to facilitate communications. These modem chip connectors control information circulating between the two computers. The fax modem is installed. The power supply transforms electricity according to the voltage required by the different components. The computer's interior cabling is installed. It allows information to travel between the different media and the motherboard. The IDE cable is connected and the CD-ROM. The last electrical wires are connected to different computer components. The assembly of 30 components of the computer is now finished. Just before closing the case, they test each computer to verify the good functioning of the peripherals. Then they close up and proceed to packaging. This company produces about 300 computer units every day. Fabric is made from thousands of braided threads. This mill has 700 bobbins of polyester. Each bobbin contains 250,000 meters of thread. We begin by separating the threads. This warp unit takes the 700 strands and assembles them. Then this comb separates them. Other strands are added, and in total, there will be 7,000 of them well aligned. One fabric is composed of threads braided at 90 degrees. The warp threads are assembled lengthwise, while the weft threads are joined transversely. To prevent the threads from tearing, they pass through a bin of glue. These rollers eliminate the surplus. The glue will be removed with water before dyeing the threads. The glued together threads exit this machine. These large green cylinders are heated and dry the glue on the threads. Knitting will soon begin. The 700 strands are newly separated on this loom roller. Each thread must pass through a blade to produce a specific design. This machine takes the 7,000 strands of thread one by one, and they pass through the blade. It's a highly precise operation. The threads pass through a blade, and the weaving finally begins. On this Jacquard-type loom roller, the warp thread is inserted by a jet of air. The weaving machine assembles 2 loom rollers made of 7,000 strands. The fabric reaches a width of 3.65 meters. The dark threads are inserted into the weave. They insert 600 weft strands per minute. The blades remove the weft strands to insert the warp ones between the two. A comb pushes the weft. The plate of the breakage chain stops the machine should a thread break. This bobbin contains 250,000 meters of thread. That's 250 kilometers. The weft thread is in the insertion nozzle. When a weft is inserted, an air jet nudges it in. The loom roller operates at full tilt. It makes 600 thread intersections a minute. Weaving is now over. We move on to the following steps: washing and dyeing. Washing is done in a soapy solution at 80 degrees in a continuous manner at a speed of 60 meters of fabric a minute. The fabric is rinsed in clear water of about 30 degrees. Now it's on to dyeing. This is done with jets. Up to 12,000 meters of fabric are placed in clean water into which colorants have been added. The solution is heated and the fabric soaks here for about 6 hours. Then it will be rinsed in lukewarm water. The fabric is placed in a bin. This machine is called an opener. It unfolds and stretches the material before rolling it up on an immense roller. And now the roll is almost full. We now move to thermosetting in a high-temperature oven which dries the fabric. The temperature is 200 degrees centigrade at the oven's entrance. The fabric circulates here for 45 seconds. This finished roll weighs 1,500 kilos. The bobbin that we saw at the beginning has produced 25 kilometers of fabric. Making a nylon stocking takes only a few minutes. However, it's a complex operation that involves the knitting of 5 to 8 threads as fine as a hair. The threads, usually nylon and spandex, strong and elastic, are used. Sometimes polyester or cotton are added. The knitting machine goes into action. This one fashions a tube for sheer stockings in 90 seconds. In 3 minutes, it makes a tube for tights. Its speed is adjusted according to the product being made, varying between 750 and 1,200 revolutions per minute. Once the tube is knitted, it is sucked up and lands in a bag where it will be inspected. More than 500 machines share the work, each making a model that is specific for it. The two ends must now be joined. This automated machine assembles the two tubes together to form the pantihose. Then a scissors cut the pantihose, a necessary step in production of a pair. This opening is enlarged to allow for sewing, which will join the two tubes at the point of the panty. The label with the size or brand name is already sewn in place in just 10 seconds by this robotic machine. At this pace, it sews on 4,800 labels in 8 hours. Installing a gusset requires some preparation. A scissors makes a hole at the joining point. Then the stocking is turned inside out by suction so that certain stitching can be done on the inside. Thus, these stitches will be less visible. Now the foot must be sewn. This robotic machine places the foot in position. Then a sewing machine makes stitches at the same time that it cuts away excess material. This step requires only 10 seconds. Then the pantyhose is turned right side out, again using suction. Everything is ready for installation of the gusset. The pantyhose is placed in a tub and taken to this department. The stocking is again suctioned and placed on a gusset machine by the operator. This method assures that the gusset will be installed well-centered without a pleat. Putting in the gusset is the final operation in the process. A pre-cut piece of cotton is slid into the space reserved for the gusset and automatically sewn in. Only aesthetic touches remain, such as adding a little color to the pantyhose. They're placed in this machine, which has a large drum with 4 compartments and a 45-kilo capacity. The pantyhose are washed in soapy water, then immersed in dye. Temperature climbs gradually to 93 degrees centigrade. After a 5-minute rinsing cycle, a softener is added. This all takes 2.5 hours. Once dried, they proceed to inspection. The pantyhose is placed onto a form which stretches it to allow inspecting for any imperfection. If all is well, the pantyhose is transferred onto another metal form where it will be pressed. The pantyhose is positioned, guided by a magic eye. The pantyhose is then carried toward a steam room, remaining there for 2.5 seconds before being dried in 7.5 seconds at 140 degrees. They fold and pack 420 pantyhose per hour and make 180,000 pairs per day. Used tires are a real source of pollution. This pile represents about 100,000 of them. At any rate, these tires will have a second life. They'll be recycled to make rubber mats. Each day in this factory, they recycle 15,000 tires into mats. Tires have to be reduced to little granules, but first, this conveyor feeds the tires into the washer. Tires are washed with a water-based biodegradable preparation. Then they're sent to the shredder. The shredder has 2 rows of large teeth. These grind up the tires into pieces. This shredder is able to cut up almost 1,000 tires an hour. They come out as fairly good-sized pieces of tires, which are then shredded a second time. Metal is magnetically separated from the rubber, and the metal pieces are recycled at another factory. Other components of the tires, such as fiberglass and nylon, also have to be separated. They use a sifter to get out unwanted rubbish. Recuperated rubber particles purged of foreign materials measure about 2.5 millimeters. Some 16 tons of tire particles are piled up in this recycling depot. But the particles are still too large to be used. They're sent to a secondary shredder's supply tank where they'll be reduced even further. This tractor feeds the secondary shredder. Grinding action produces a kind of rubber powder. The powder is spread out on these enormous molds. This mold has a length of 7 meters and a width of 1.2 meters. Thickness varies according to the product being made. The molds filled with rubber powder are stored in this loading magazine of the press. Once full, the molds are sent to the rubber mat press. Here's the mat press. The powder has to be cooked at a very high temperature for about 30 minutes. Cooking time depends on the product being made. The cooked mat goes through the unmolding unit before being sent off to cool. The rubber mats are still extremely hot. They're cooled with jets of water for a period of several minutes. The cooled mats can now be sent to the next department. This conveyor in the cutting center positions the mat before it's cut. The mat is vibrated to eliminate any surplus water. Each rubber mat is now cut up into 3 pieces. The cut mats are then stacked into a pile and stored before being shipped. The company also makes mud guards. These are fabricated the same way as the preceding mats. After having been cooled in water, but while they're still warm, they remove the surplus rubber. This operation is called notching. Hard rubber rings are also produced at this facility with the same fabrication methods and, as always, from old used tires. Over a 12-hour period, this facility makes no less than 12,000 rubber mats from old recycled tires. This translates into good news for our environment.